Hello and welcome to Routing Concepts. My name is Zahid. This course will be a complete guide to understand and implement MPLS technologies. Now, in terms of today's agenda, first thing we're going to discuss is overall overview of the classes in terms of what the topics that are going to be covered, what is the format that we are going to cover. So next then we have the slide on the course content. This course has been divided into 9 lessons and each lesson has its own sub-lesson, starting with the basic MPLS L3 VPN architecture and naming conventions. So this is the building block for understanding what makes an L3 VPN, what are its components, and where do they fit in. Next, we will discuss about LDP protocol, LSP FEC and other common terms in MPLS label switching. From here, we will create our first lab and implement IGP and MPLS LDP label switching. In our next chapter, we will configure our first MPLS L3 VPN. Here we will configure MPBGP. Then we will configure VRF. We will configure different flavors of PEC routing. Once all the configuration is done, customer traffic should pass through our network. Then I will start giving you some MPLS L3 VPN lab challenges that you have to complete. By the end of this lesson, you will be able to configure most of intra-AS MPLS L3 VPN scenarios. In our next chapter, we will be discussing about inter-AS MPLS L3 VPNs, where we will go beyond our autonomous system border router to connect with different service providers and exchange our customer VPN routes, starting with the high-level overview. What are the different L3 VPN options? What is difference between option A, option B, and option C? We will look at the configuration of each of them. And in the last topic in this session, we will look into carrier supporting carrier or CSC feature, which is used for what is sometimes referred as hierarchical MPLS L3 VPN. When one L3 VPN provider is using another L3 VPN provider in order to get long distance transport. Then in the next chapter, we will design, deploy, and optimize E-line, E-LAN, and E-tree, or VPWS, VPLS, and HVPLS. And then we will move to EVPN, EVPN VPWS, and EVPN IRB. In our next session, we are going to begin discussion of MPLS traffic engineering. And first, I will give you high-level overview of what traffic engineering is, what are the different features it supports, why would we run it, and then we'll get started into some basic example of implementing it with ISIS and OSPF, and then get started into the more advanced features as we start to drive into a specific CLI configuration. We will review MPLS forwarding decision matrix such as bandwidth, shared link risk group or SRLG, affinity or link coloring, manual path selection, and service type QoS based forwarding. Then we will move to the topics like RSVP, faster reroute, impact on PIM for multicast, and other topics. Then in our next section, first we are going to have overview of what segment routing is, or what are the basics of segment routing, what are some of the features that it support, and how the segment routing differ from MPLS LDP. We will look into label allocation mechanism and segment routing control plane and implement the configuration of segment routing with OSPF and ISIS. We will also take a deep dive into some of the other topics of segment routing such as performance measurement, path computing element or PCE, path computing client PCC, topology independent loop free alternative or TILFA, flex algorithm, and SROAM. And finally, we are going to have more advanced topics like segment routing traffic engineering or SRTE, where we will work with different types of traffic steering such as dynamic and explicit paths. Then we will have some labs for migration of MPLS LDP to segment routing, where we will use mapping server for label distribution. Finally, we will cover the last subtopic, segment routing over IPv6, or we say SRv6, which is a massive subtopic in itself, and we will spend a good amount of time in few of its labs. In our next chapter, MPLS QoS, we will start with the basics of QoS such as classification and marking, congestion management and scheduling such as policing, shaping, and queuing. Then in congestion avoidance, we will look at tail drop, RED, WRED. Then we will look into MPLS QoS models such as pipe, short pipe, and uniform. And the last sub lesson will be MPLS TE-QoS, where we will discuss about MAM, RDM, CBTS, PBTS, and DSTE. In our last chapter, we will discuss about multicast, starting with protocol independent multicast and its modes such as sparse mode, source specific multicast, and bidirectional PIM. Then we will look at a Randor's point where multicast source and receiver connects. Different types of Randor's point are automatic Randor's point, bootstrap, static, Anycast RP, and multicast source discovery protocol. And finally, we will move to multicast label distribution protocol, internet group management protocol, multicast listener discovery, and we will deep dive into multicast distribution tree design. Before moving further, starting any of the topics, we are going to install EVNG for our lab purposes. In my next video, you can see how to install EVNG on your Windows machine and install iOS XE, iOS XR, and IOL routers for our lab. So let us begin.